ANSYS Workbench tutorials. In this session, we are going to analyze a beam bridge for static structural analysis. The highlight of this video is the making of the beam bridge. These days, if you look around, a lot of metro have been using a beam bridge as a structure. So we will be analyzing it using static structural module. So I'll go to static structural and double click on it. We will leave the material as structural steel, which is the default material of ANSYS. Also, you know that a lot of structures which are used in bridge making makes use of structural steel. So we will start with geometry. Right click, new design modular geometry, units, millimeter, XY, look at, sketching. Okay, this is how a beam bridge looks like. So we will try to make this lower portion first. I'll choose polyline and I'll draw the outer surface. Right click and close it. Next I'll go to constraint, symmetry. About this line, I'll make these structures symmetrical. These two as well. And these two lines also. Next I'll go to dimensions and I'll give them some dimension. Say this is 100. This dimension is 50. This is 50. This dimension is 15. And this dimension is 10. Next I'll go to extrude. I'll select the first sketch, apply. Say I extrude for a depth of 20 mm, generate. This is made. Next on this face, I will make this structure. So I'll select the face, new plane, generate, look at. I'll choose rectangle and I'll draw a rectangle over this. I'll go to constraint and choose coincident for these two lines. Now I'll give this a dimension. So let's give this height a dimension. Say it is 150. Next I'll extrude this. Say this dimension is 20 and here instead of add material I'll go for add frozen, generate. You can see here this is how it looks like. Next I'll go to create, body transformation, translate. I'll choose this body and I will say that I want to preserve this body and also translate it. Next I need to give some direction, so I'll choose the direction as coordinates. Now I'll be drawing it on this side. It's going along the positive z axis, says at a distance of 40 mm, and I'll generate. They are all equidistant. So I'll go to create again, body transformation, translate. I'll choose this body, apply. Again I'll select coordinates, preserve body, yes. Say this is at a distance of 80, generate. So this is how my beam bridge is going to look like. So this is a simple geometry that I have created for a beam bridge. This is how it looks like. It's just the distance that I have chosen is little lesser. You can give more distances and you can create accordingly. Now I'll go to model and double click on it. I'll go to mesh, right click, insert, method. I'll select all these bodies by pressing the control button, apply. For method, I'll choose hex dominant, update. I'll go to mesh again, right click, insert, sizing. Let's choose all the bodies again, apply. The element size by default is 8. I'll make it as 2 mm, update. This is how the mesh would look like. You can make it more fine by reducing the element size. I'll go to static structural and insert fixed support on these ends. On this surface, I'll insert force. I'll change vector to component. You can see the direction is y. Let me apply a force of minus 5000 Newton because there will be a metro moving over it. So let me assume the mass is 500 kg. When I multiply with acceleration due to gravity g, let me assume it as 10 meter per second square. So the value rounds off to 5000 Newton. Next, I'll go to solution. I want to see the result of deformation directional along the y-axis, stress equivalent, and I want to see the strain equivalent on the body. Also, let's go for choosing of the fatigue tool. Here, I'll choose the load as fully reversed. You can see it will be loading, unloading, loading, unloading. This is a sinusoidal kind of loading on the bridge, which is generally what happens when a metro moves over it. Here, the analysis type, I'll leave it to stress life and mean stress theory. Let me choose as Goodman theory. I want to see the result of life and the safety factor. Also, you can go to probe and choose moment reaction on the fixed supports. Let's go to solution and solve now. This is the directional deformation over the beam bridge. You can animate and check the result. This is the equivalent stress over the bridge. This is the amount of strain on the bridge, which is actually very less. You can see here the value is 5.827 into 10 raised to minus 5, which is very, very less. We can see the life of the bridge. The value is 1 into 10 raised to 6 cycles, which is quite large. But obviously it is going to fail because you can see here the actual life or the design life is 1 into 10 raised to 9 cycles, but it is working only for 1 into 10 raised to 6 cycles, after which the bridge requires maintenance and repair work. Here you can see the factor of safety is 7.4137 over the bridge, which means your bridge is going to be quite safe to use. Also, if your factor of safety is more than 1, please note your object is going to be safe. Here the value is 7.4137. And this is the moment reaction value along the x, y and z direction. And this is the total value of moment. So that's what you can check over here. So these are the expected results for a beam bridge when you design and analyze it under the static structural loading. Also, I have shown you the fatigue analysis of this bridge in the same analysis. So with this, I end the session. I hope you have understood how to analyze a beam bridge for a metro moving over it. If you have any doubts, please write to me in the comment section. If you want to see any particular analysis, again write to me in the comment section regarding that. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.